Hello, I'm Chris. I'm a KMP developer. Today we're going to be getting into the Internet of Bugs. My new favorite channel. This guy's definitely been in the pit for a while, and he like gets it. And yeah, that tech sport's coming out on Tuesday for that. Close that up. So yeah, so this is what we're gonna get into. And I only got about a third into this, and I started reacting to it. It's like might as well share it with you guys. Okay, all right, let's get into it. Let's go.
The idea of what makes for good code and what makes for bad code. It's a huge topic and it's got a ton of corner cases, so I'm not going to be able to do all of it. I'm not even really going to get much but a good start. What I will say is that most of the advice that I've seen about what makes for good code is crap. And the reason that it's mostly crap is because it's not really based on any actual principles or heuristics, and by which I don't mean that they don't have things they want to accomplish, but those things they want to accomplish don't actually map to making things better in the real world, except in some hypothetical kind of sense. I have a very
Yeah.
different take
Okay.
on it.
So
I'm going to kind of try to walk you through that. And hopefully by the time we get to the end, assuming you stick with me, you'll see why it is that I think that most of the advice is garbage.
yeah, okay, yeah. So I agree completely, 100%. I call this in my course, I call this book-driven development or conference-driven development. A lot of these books came out, and honestly, I'll just say right out the front, this is a failure of academia and specifically computer science education. It's terrible. It has not changed since about the 80s. The technologies and the techniques they're using were employed in the 70s for most of the stuff I've seen. And there's this major disconnect between this very low level training that we get and what's actually being used in industry. And it's two levels removed at this point. So, um, yeah, so the expectations level and what's being taught is a failure of computer science and academia. I think that whole thing became a scam in the 90s or 2000s when they allowed anyone to get federal loans for couldn't pay them, couldn't be dismissed in bankruptcy. That made the these so-called educational institutions just big money grabs. So that's a major failure, and these books are a direct result of that failure. I'll just keep going.
Especially this thing. I did a video not long ago on programmer books, and there were some people that said I should have included this. There were a lot of people that said they were happy I didn't include this. I hate this book. I hated this book long before it was trendy to hate this book. I took it seriously for a very short period of time, and then it became obvious to me that the advice in here is bad. I mean,
It's worse than bad. It's terrible. It has a couple narrow use case ideas, and for the time, there was literally nothing else. So this is a failure of the academia and the computer science education and industry as a whole for not taking some of their knowings because for profits. Right, this is all profit-driven business oriented thing. Instead of employing, driving that education down into the next generation, they kept it for themselves and kept their little fiefdoms and tried to keep their little domains, and that's all going to crash, of course, with this AI things that they think is going to take over, but it won't. But it, yeah, there's just no way around having humans in the loop. And okay, let's keep going.
it's harmful. I'll get into why. I'll talk about a couple of examples today. But just for the record,
Yeah, agreed.
there's one for the thumbnail. This is the Internet of Bugs. My name's Carl, and we're talking about coding advice on how to make maintainable and clean code. One thing about most of the advice, this goes for actually clean code, a bunch of other things, a lot of design patterns. They're very specific to a specific language. And a lot of the principles that they talk about that are important are things that are not important in other languages and are not relevant in other languages.
Agreed. So for back end people, the clean code stuff does hit a lot of targets for them. I mean, sort of. But for front end, we're like going, what? I mean, okay, yeah, you can split it up that way. It does make sense in some cases, but some of this other stuff is like, what are you talking about? And it's like, no, this applies to all engineering practices. Like, no, it doesn't. And in fact, that's what engineering is these trade-offs between techniques. And you can't just have a pat answer for these things. These are struggles you have to go through as an engineer and as someone who's trying to solve problems for humans.
I have a set of ideas that I think are way more applicable because I've worked in a bunch of different languages and I've worked in a bunch of different frameworks, and I have found the same techniques to be useful over and over. Things like clean code create an opportunity for teams to argue with each other and for people to point to things and to tell each other that they're wrong, and it just creates contention in a group.
Like they call bike shedding.
And that's
you're discussing stuff that doesn't really matter, and it's because it's said in a book somewhere. So there's this appeal to authority because of the lack of education, right? We have this appeal to authority because people don't know. They're thrown in the deep end. It's like, we don't know how to solve this. And no, you have to do it this way this week. And we see these other guys doing it, so you can do it too. It's like, no. And there's different engineering practices, different use cases. It's all different, and most places are product focused, and they don't really understand what's involved with engineering these things. And when they see the costs involved with actually creating a real solution that actually delivers value to your customers, they're like, no, we can't do it at all, or they do it half-ass, and they just market it as the most amazing thing either, but they know it's really not. And by the time their customers figure it out, they've already gotten their profits and they're on to their phase B of their funding. So that operation, that's gone. That 0% rate environment, that's gone. Okay, so the scam days are over. So now it's like you're culled out the people who were just grifting on it, and now we have to actually provide real value. And that's the thing that I'm looking at as well with the KMP, is like leveraging one developer and having multiple platforms. So like that's so we can at least springboard into something, and not and do and actually provide real value and not fake just to get to the next round of funding thing. That's over.
Pointless, especially when a lot of the advice actually takes you the wrong direction. So I try really hard to make my advice based on my experience and based on what I've seen and what I've discovered over the years, maps across a bunch of different languages and a bunch of different platforms. Hopefully as we go, you'll see that. So to start with, the point of code maintainability is to make the code easier to work on for someone who's unfamiliar with it.
Right. The point of code maintainability and just writing code in general is not to make it easy for you. It might be your first program. Oh my God, I got it to work. No, it's to get other people to understand it. And your fancy like TypeScript algorithm, Turing complete. No, that's not helping. That's actually giving you job security, yes, but only in a ZPR environment. When you actually have to provide real value that's not obfuscated, yeah, that goes out the window.
Not to make it easier for you to write in the first place. There's a lot of hypothetical garbage in the advice on how we write code. It's not about some hypothetical how changes might get made in the future. It's about how do you find the places that changes need to be made now, and how do you assure that you're correct in that and that those changes are isolated.
Right, and that's planning. You can't just get out the break things and move fast. No, that's how you create a lot of just garbage that just turns into sludge. And you have to plan these things out. You can't just jump into them. And you have to like know what you're going to try and do and isolate these areas so you can have multiple people working on them, not stepping on each other's toes. Like this is the hard problem, not this other stuff. Like, this is okay.
It's not just how easy it is for somebody who's not you to maintain your project, but you'll find, if you've been doing this a while, that it's very often the case that you're away from a project for a while and then you come back to it and you have to figure it out all over again.
Right.
It's not at all unusual for me to be like, okay, what idiot wrote this? Oh, look, I did 6 months ago. Second principle, code is generally not read. You don't start at the top of a file and read down and then go to the next file and read down. Not if you have a choice, at least. If the only way that you can understand a code base
not with millions of lines, definitely not,
is to read it like that, then the original author failed. There's one.
Yeah, you can't know the whole thing to understand the system. You can't know all the assembly language instructions down the bottom of the core to the binary machine and be effective and efficient and like even being useful. That's not useful.
Exception to this. There are times that I'm hired to audit code. Basically, I'm brought in to evaluate the progress or lack thereof that some other developer has made. And in that case, I do often read code from top to bottom. But in that case, I'd argue I'm not really maintaining it, and it's not about maintainability. I'm auditing it, really. So that's a different case than that one.
You're looking for something else. You're not trying to how to figure it out and fix it and change it for the next guy, or to make it easy for them, or which is you, or whoever that person is. For humans, computers don't give a crap. They'll run whatever. Humans, this is for people. I know it's like, people, we're writing code for people. I was writing it for the machine. Like, no, it's for people, and more likely you. I mean, that's the cliche, but honestly, it's just stop the you thing. Just for other people.
Talking about. Aside from that, I never read.
That's why we're paid.
Code from top to bottom if I have any choice at all. This is where most of the literature fails utterly. I know as a published technical author myself that it's really hard to write code listings so that they can be printed out on dead trees and bound into a book so they can be understood. It's difficult and it's a skill to get it to work that way. But if you think that it makes
that's not even a goal. But go ahead.
Sense to optimize your code so that everything is 2 or 3 lines, and something that should take half a page ends up getting spread across 3 pages so that typesetter has an easier time of figuring out where to put the page breaks. I think
you talk about how clean code just wasn't that like line, not write more than 5 lines. Like, come on. Really? So you have a bunch of lines all over the place. So you're spending all your time flipping back and forth between these files that have 5 lines in them. Really? That's efficient? Stop. You'll notice that a lot of my code, it's a big, long, like especially the compose stuff. It's like I put everything that needs to be right there. If it's in that file, I'm putting it in there. So everything you find is right there. If it needs to be someplace else, it'll be someplace else. But if it's not used by anything else, it's going to be right inside it, and it's going to be a long file. And the IDE lets you collapse down the lines, so you can only look at the sections you want to look at that are important for what you're doing at that moment. That's the whole point. Is it's like you have to collapse down this. You can't keep it all in your head. That's just, yeah, people that do that and they expect other people to do that are just no.
You're valuing the wrong thing. So here's a listing from Clean Code, pages 30 and 31. If you can't tell that the goal here was to have a lot of different places that page breaks could happen without the reader having to turn pages back and forth, I don't know what to convince you. All of that code could have fit easily in 3/4 of a page. But
Right. Right. So this is make work here. This is making things harder for no reason other than we're just going to break it up so it's not in one file. Well, okay, that gets you what now? Okay, maybe this was appropriate when the IDs couldn't do collapse, but now you can collapse down blocks of code. Why? Why? You're basically just putting it in another file. So instead of putting it in another file, you put it right there, and it's always right there, and you collapse it down, so it's always available. And if you don't want to look at it, you don't look at it. Like, come on.
but it's all spread out to make it easier to typeset. I thought about actually drawing arrows so you could actually see the flow of the code.
Oh,
But
it's
nope.
terrible. I've worked on plenty of code bases like this, and this is why I'm like no view models. Like try and make everything in one place. Okay, if it needs to be testable, we'll figure that out later. But right now, we're just doing it this way. So it's just easy to read, easy to write, and somebody can, they're not jumping around all these different files, having 65 windows open. No, with like tiny little slivers of them open. What? No.
No one's going to be convinced by that. Either you're going to look at it and you're going to realize that it's stupid, or you're not. And if you think that that's the way code ought to be written, I don't know what to tell you. In the real world, the way people figure out code is from the bottom up. When I'm going to fix a new
Well, there's a reason for it. It's called no education, lack of experience, no information coming back from industry in a real cohesive way. Except for we're going to go to Harvard and do a Harvard. Like, if you just checked out that Harvard course, it's terrible. It's terrible. You don't like that is just not the way to learn computer science. Sorry, you can take my course. If you take my course, you can take that one after, and it'll make more sense. But the way they teach it is terrible. I went through the course; it's terrible.
code base, right? When I'm brought in to work on a code base, it's never
This is computer industry people. I guess they think this AI stuff is going to be able to solve their problems for them, so they want to keep their little fiefdoms going, but it never lasts. That stuff looks. They're trying to create a little. It's they're silly. Okay, keep going. Stop stuttering.
ever the case that someone brings me in and says, okay, here's a new code base. Go take a look. Take a week. No big deal. Read the whole thing. Figure it out. All that kind of stuff. Never happens. What happens is I get brought in to work on a new code base, and there's already a list of we need this fixed, and we need this fixed, and we need this fixed, and we need this added. There's always a laundry list of stuff that's already needs to happen. If there wasn't already a bunch of stuff they needed to get done, they wouldn't be bringing somebody else in. So
Right. Right.
what you do, what I do, what most of the folks that I've talked to do is we start with a bug. We start with something in the bug that tells us what's going on. We look for an error message, for some on-screen text. We look for a log statement, something that's in the bug report, and
That's why those things are super important to like have good error messages and good error handling from the beginning. What is expected? Because when things start to change, that you like when people start changing the code, they got to know what things are not going right and why, so you can fix it easier, faster, not just error.
then we search for that string in the code base. And we figure out, okay, here's the place where that string gets printed. Here's the part where that string shows up on the screen. Okay, I know I'm around here somewhere. Let me read this part. Okay,
Yeah.
cool. Now, how did I get here? Then you go take your editor, you say, right click, show me what function called this.
Yeah.
And then you jump up a level. And then you figure out, okay, so now I know what's going on.
Yeah, it's always like this. You never go in with perfect knowledge of how the project works. Otherwise, you wouldn't be hired. The guy just do it by himself. It's always like this. So how can we make this part better? How do we make this part so when we have these changes, things are going crazy, and we're bringing in new people, they don't have to like struggle and ask me how to do things. It's like I've already kind of shown what could be going wrong by leaving these messages at the time I was writing them. I was like, okay, I expect this here, I expect this here, I expect this. If this goes wrong, then like I'm gonna verbose about it. How do we convey that to other programmers? Like, this is really super critical, not for you and not this week, but next week for someone else, so they don't come asking you, and we can move forward. Like, this is where computer science is falling down. Because computer science really isn't about the machines; it's about communicating ideas to other humans in code. That's really it.
On here, right click, go up a level. And that's how you trace code, right? And that happens not just the first time, but bug after bug after bug after bug. It's occasionally the case that I'll get a bug and I'll know right where to go, but generally that's because
Right.
there's a bug around there that I've already had to deal with.
Right.
And it's not at all unusual for me to be working on big code bases and work on them for a year, and there'll be a chunk of that code base that I've never even looked at because I've never needed to, because there hasn't been a bug in there that I've had to worry about. So many code bases just utterly fail to make any sense this way.
Yeah.
And a lot of times it's because of these top-down techniques that supposedly make code more clean, but actually just obfuscate everything. One way that happens is
It's so true. So this is the problem.
you have a whole bunch of different subclasses that are just tiny little variants of each other, right? So I'll say,
so somebody like who needs something. So what happened was somebody needed something. They looked around the code base. They couldn't make sense of it. And like, well, I gotta get this ticket out. It's Tuesday. I got 3 days left on this ticket, so I'm just gonna write my own version of it. And the code bases are littered with these things, and no one. And it's just because you can't. If someone needs to get a ticket done, there's 6 other members of the team, and this thing's compiling, working, running, testing, blah, blah, blah. They are not going to question, okay, there's 65 other ones that are doing almost the same thing as that one. Could you use that one of those? No. So this is how the code bases die. This is what happens. And this is not even talked about. Getting the ticket, getting the sprint. Sprint, really? Sprint. Ship this thing before we go out of business.
hey, IDE, right click, show me what method calls this. And I'll get like a dozen answers because there are all of these subclasses that all do different things. And I have no way of knowing which one it was.
And guess what? We're going to go through all of them. We're trying to figure out, because this is how else are you going to do it? How else are you going to know? Before you have to set breakpoints and all of them. It's like, where's this coming from?
That happen to be calling this portion of the code when the bug happened. And so now I have to give up on being able to find it in the code base.
Right.
I have to switch gears. I have to get the thing up at runtime. I have to reproduce the function. I have to figure out how to debug it or add print statements to it or something, so I can figure out.
Welcome to paradise of the developer. All caused by the previous actions, and these compound. Right. This is where people talk about the technical debt. The technical debt is this stuff. The technical debt is caused by this stuff. Nobody wants to hear this stuff because the people that are running the product, right, are usually like, okay, I got this guy to give me some money because he found a guy that gave him the ZPR loans for cheap, and yeah, he's willing to bet on this thing. And if this thing better work this week, this thing's gonna ship this month, or I'm cutting off funding.
Which one of those classes was the one that was actually there when the actual bug happened, and then I can continue working up this.
And they come in like after they get the funding, then they bring the people. It's like, could you fix this for us? It's like, yeah, but it'd be better if you didn't write it this way. And like trying to communicate, well, do you have a book or a conference we can go to? And this is where it starts.
Stack. And that's just a nightmare. It takes way more time than it needs to. So here's a listing from chapter 10 of Clean Code. This is page, I think, 148 or 149, something like that. I don't know if your edition's the same as mine, but when you're trying to
it's really important which page it is. Like, we can't go look it up, sir.
go up.
All right, I'm sorry.
Code, and you hit something like this with all of these different, this extends SQL, you've hit a dead end, or really you've hit a maze of twisty little classes that are all alike, and there's no way of knowing which one's which. It's a productivity killer when you're trying to figure out
a productivity killer, really? Really, a productivity killer, like it's the technical debt they're all screaming about, is this stuff. Yeah, total productivity killer, because why? Because they were rushing, trying to put these classes together because they couldn't figure out which one, just the same problem you just came into, and they solved it the way they could solve it. That made their boss happy. He didn't ask questions. The ticket got done. The thing's in production. It's running.
what's going on, where this bug came from, or where this feature needs to get added. In the case where I do manage to get up to the top-ish, and so I have some idea of the slice of the app that's actually relevant to what I'm working on. Hopefully I didn't have to go to runtime to figure that out, but
oh, you're going to runtime. With this kind of environment? Oh, you're going to runtime.
Once I figure that out, the next idea.
Why I laugh is because it takes so long to figure this stuff out. I worked at companies where all the team that designed it had fired. They moved on a long time ago, and I was brought in to fix their stuff. It's like, do we have any kind of spec? No spec. Just look at the code. Look at the code. This code is a nightmare. Who wrote this? What is this? Nope, just figure it out. I got 3 more days in the sprint, so you better get a test in there too. Yeah, okay. You got it. Is that what you want? Okay. We're doing it that way then. Because we could do it. No. All right, never mind.
Is that everything that I need to do in order to change the bug that affects this thing down here should be part of that slice. I mean, not necessarily the exact methods all the way down in the stack, but this class and this class and this class, or this object.
Right. This is education. This is education. This is the education that people need to get that they never get. Not even in graduate school. You think they're at PhD level would be working on this project? No, because when they get the PhD route, the master's route in CS, they're not going to business. That means they suck at computer science. The ones that suck going to PhDs, they don't even know the problem space. They don't even know that this is going on. They're like, well, can we make sure it's computable and can we refine the AI? No. Can we fix this? Could you get some education level? Like push it down. Like, can we do this to fix this? No. We're just gonna do an AI model that gets rid of the programmer. Is that what we're gonna do? We're gonna do a Devin. Good luck.
In this object, or this function in this function in this function, or this file that calls this file that calls this file, right? The rest of the code, the rest of the application, hopefully, is not containing stuff that's causing this particular bug, because that makes it really, really hard to chase down.
Static classes. Anyone in Java? Statics? Anyone? Never heard of them? Oh, okay.
So that's part of the whole code isolation thing, right? So the corollary to that is when I make a change in this stack, that change that happens in this vertical part of the application should not break stuff elsewhere in the application. So this is where you get these.
Right, that part of the clean code, I agree with. Okay, I agree with that part. The shell, we got the core application, then we have this API layer, and then we have the operating system, whatever the external is. Yeah, I agree with that.
Maxims like no global variable.
Yeah, statics in Java. No, it's not global. It's just a static variable. It's not global. I've actually had engineers tell me that. I'm like, it sounds like it's a global. No, it's not a global. It's static.
Single responsibility principle, open close principle, all this advice that you get basically boiled down to changes here shouldn't break anything not here.
Right. That's the basic idea. I wish they would have just said that. Changes here. If I switch something around here, it's not going to blow up something over here. Like that doesn't seem to completely relate. Like I should change this over here, and it changes just this, not this. But we don't get that because it's hard to separate those things out. You have to think ahead of time, right? It's easier just to go grab it. If I need it, I'm just gonna grab it. Well, if you have everything grabbing each other all over the place, if you change something over here, if you change that one thing over here, all these other things that are grabbing it are also going to need to be changed. And you're going to be productivity killer.
Saying it that way, saying changes here shouldn't break anything not here, is harder for a beginner to understand. It's a lot easier for a beginner to understand no global variables, right? But it's not at all unusual for me to find projects where that's completely violated. It's
completely. It's the standard. They hear, okay, no global variables, but can I use a static? Because I'm in this way down over here, and I really need to get this thing that's way over here. And to make that actually happen, I have to go back and rethink the whole program from the top. Can I just go get it over there? Well, that's a static access. You really shouldn't do that. Well, but I can do it, right? Yeah, but and then and then you get unmaintainable. And then you have people like, we can't get rid of the technical debt.
a state I call whack-a-mole. I wrote about it in my book, where basically every time you change something here, every time you fix one bug, some feature that used to work stops working somewhere else. It's a nightmare. And it has killed...
Nightmare, yeah. Total nightmare. This is what causes burnout, is these types of decisions that get compounded. And the clean code is like a desperate clawing attempt on a life raft after the Titanic is shaking. Can we please get something? Please, some clean code or something? No.
More projects than anything else that I've ever seen. And it usually happens right at the end of the project when everything is trying to come together and you're doing final QA, and then, oh, there's a bug over here, and then you fix that, and oh, there's a bug over here that wasn't there yesterday. And it's always the result of poor architecture, poor leadership, poor developers.
That's not poor developers. It's poor education about how to build these things. This is never discussed. You have to find it along the way. And the people that know how to do it and have figured it out, guess what? They're not telling people how to do it. Yeah, did you know that? Because they're making money with this stuff. Making empires. What do you think's going on here? This isn't a fucking charity.
Maybe the developer was incompetent. Maybe they were...
Yeah. They hired a bunch of people that didn't know what the fuck they're doing because they learned how to use code on the internet from the people that didn't know what the hell they were doing because they were trying to get up on this thing. What are you talking about, man? This is not a charity. This guy's old school. I'm old school. So we kind of saw how it was for a while before the boom thing happened. And it wasn't like this. It was much more like academic, and people are much more curious about technology and how to build things, right? And we were all sharing stuff all together. It's just, that was how it was. And then it stopped. And then the boom happened. people saw these billion-dollar industries, billion-dollar companies coming up. They're like, I want to get in on that. And they said, oh, you want to get in on that? Well, I'll tell you how to get on. And they wrote books like Clean Code, which confused people even more because they were so desperate for the money. Hello? This is where I kind of lose it with some of these tech people. It's like, hey, this is a money thing, guy. Yeah, people are trying to get rich and like shove people down that coming in the competition. What do you think? This is blood sport. This is elbows knocking each other the fuck out, stealing developers that know how to do this stuff, putting them in blocks. It's like, don't think anything. Please don't compete with what we're already doing because we just need a few more months to get ahead and you're going to be moot. Yeah, what do you think's going on out here? This is the game. This is what's going on. I know it's hard to take.
Over their head. Maybe they weren't paying enough attention. Maybe they just didn't care enough. It's hard to know.
They wanted it for the money. They weren't in it for like what we were in it for. We were like super interested in the technologies. That's for little kids. That's not what they were. It's economic, dude.
But by the time you get to the end of the project and you get in this whack-a-mole state, you generally can't fix that without making major structural changes.
Yeah, it's called planning ahead. Yeah, but nobody knows how to plan ahead because this is probably one of the first or second projects I've ever been on. They just got sniped from another company that was barely making it on a previous thing that was shakily put together by someone who was like super clever and knew all the details. What do you think's going on? You think that person's like telling them all of the? You can't convey that information. You have to build it up from scratch yourself and see all the issues and try and put it together. No.
It just caused the project to go way over budget and way over time.
Really, way over budget, way over time. Wow. You telling me the last 5% takes 95%? Really? This is not. No, we're almost done. We're 95% there. Oh, really? Well, you got about 95%. You got the whole project to do that you just did because you rushed through it, thinking you're going to get to the goal quickly and get to those millions. We're going to be the next Facebook.
The thing is, it's not at all unusual for me to find a project that is in that whack-a-mole state and then go through it.
Yeah, they all are. They all get to that point. That's when they start hiring because they realize, oh, shit. Oh, shit. Do we rewrite it? No, we can't rewrite it. We've got so much time and energy put into this thing. Do we rewrite? No, because we didn't. We're gonna write it again and have the same problems. Like, okay, well, that's how you feel about it. That's usually not how it works. But no, you gotta rewrite it 3 or 4 times. That's why your version 3 is usually pretty solid. If anything, version 1 and 2 are just like, what are you guys doing? And like they catch a little break, it's a little toehold. Yeah.
Through it and find out that it's got unit tests and the unit tests all pass and it's got open close principle. It's using the solid principle and it doesn't have little variables and all that kind of stuff. Those principles just aren't sufficient.
But it has static variables.
Right? You can follow all those rules and still end up with whack-a-mole because
still because it's very like the tools that we're using to build this stuff it still hasn't changed since the 90s. Okay, so it's a lot of the stuff you have to build up from building from more like basic building blocks until you get to the top of the thing, and then you can build a real application. Most people try to build it from the basic stuff up to no, the examples they give on the internet, like how to program and stuff, like how to do. No, that's not how you do any of that stuff. No, it's like toy examples. The real stuff is like at scale, super difficult, and they make it all like this way on purpose. It's money. You think this is gonna let people just come in easily and just take over their business? What do you think this is?
they're just not good enough. It's better to have the principal say, look, don't do whack-a-mole, right?
You just come and just say that? Where do you think these ZPR loans are coming from? What kind of people do you think are involved with those getting that money? Do you think they're engineering people? Or are they finance people that figured out a nice little grift that VCs are willing to fund any crazy idea because they only need 1 out of 35 to actually win? No? No? Okay.
Make sure that as you're coding, that the stuff here affects the stuff here, and the stuff over there doesn't affect the stuff here, and vice versa. So let's talk about a specific example. So imagine a hypothetical expense report app. So imagine you get a bug ticket that the user submitted receipts totaling $25.13, but the report only said $25 even. So where did the extra 13 cents go? So I've had a
my account.
Variant of this problem. It wasn't exactly this. It wasn't expense reports, but it was the same kind of thing where the amount ended up being wrong because of something that you'll find out in a minute. So for purposes of this discussion, though, I'm going to talk about it as if it was expense reports, but this is more or less an actual problem that I've run into in real life. So I'm looking for why it is that this stuff that I can see added up to $25.13 didn't end up saying $25.13, and where the hell the other 13 cents go. And I look for places that the cents get cut off. I look for places that things get rounded. I can't find any of that. I have no idea what's going on. It takes me days off and on fighting with this. I still have no real idea. And then what happens is I'm looking at the specs and I'm looking at the accounting manual, and I realize that city day in question, the per diem for that was $25. Turned out that the issue wasn't that the $25.13 was getting truncated to $25. It's the $25.13 was being ignored completely because the system had decided that those receipts weren't relevant because that person was supposed to be on per diem that day. And in this particular case, the conditions by which the program decided, is this a per diem kind of expense report or a look at the receipts from the restaurants kind of expense report, was wrong. In that particular set of circumstances, it made the wrong choice because of weird accounting reasons. This is a particularly egregious kind of bug, and it's specifically caused by the technique on page 109 and 110 of Clean Code. I will put those on the screen. What this does is it tells you that you should return an amount that's either the per diem amount or it's the total of the receipts amount, and not tell anywhere else in the program which one you picked. You're explicitly told by Clean Code at this point to hide why you made that decision from the rest of the program. And this is under the guise of error handling. This just makes me furious. They're telling you that the right way to handle a potential error is to take information that might be relevant to finding a bug and prevent anywhere else in the code from having access to that information, because
I mean, even if you're doing it that way, I just put a warning. I would use I would just do a warning in the log, like, "Hey, this is kind of strange. This doesn't sound right, but this is what I'm doing here." If it's an exceptional case like that, but really, it should error.
it's hidden inside the private part of this class, but it breaks the basic fundamental stuff over here shouldn't be affected by stuff over there thing, because it draws a line between over here and over there, and it hides all of this stuff in these private classes and doesn't let anybody else in the rest of the program see any of that information. This is an utter failure of the philosophy that goes into clean code, and honestly, most of the programming advice that you see. It assumes that you can make code cleaner by simplifying things, and that's just wrong.
No, no. Clean code is not making by the simplifying and removing information. But I mean, this is where those one of those nuanced points. It really depends on which area of thing you're talking about, because sometimes you do want to throw stuff away, and other times you don't.
Is only valid in a world where the code you're simplifying is 100% guaranteed to be 100% correct for all time, and it's not. Even if you have 100% test coverage, and they did, more or less, in the case that I ran into, that doesn't mean you understood the requirements. That doesn't mean the requirements haven't changed. It just means that the code you wrote matches the understanding that you had at the time. And in this case, as with a ton of cases, there was a corner case. There was a set of circumstances under which the original programmer's understanding was wrong. Maybe even the initial specification was wrong. It took a while for that to get triggered and noticed. But because of the way this thing got coded, it was impossible to understand what was going on without digging into the internal private methods of this one class way the heck over there that gave no indication it was relevant to what was going on over here.
And this happens so much, so much. It's the thing that happens.
The other thing that happens is a lot of times in these clean code systems, a report will come in of a bug that happens to a user, and it will be impossible to figure out how that could have happened. And it will be almost impossible to figure out how to reproduce that. And so the developer just says, oh, I can't reproduce that, and just closes it.
Yeah, that, yeah, no repro. Yeah, so this is extremely common. People will report bugs, and it's like, and there's no way to figure out what went wrong, or there's no error messages. You don't know what's wrong, and you have no way of reproducing it. Guess what? Not a bug. Yeah, did you know that?
And that's the kind of attitude that these kinds of books foster, and it's the kind of attitude that a lot of people that follow these books have, because they write code in such a way that it's really hard to find where things are going wrong, and that way they can pretend that, oh, that wasn't really a problem because it couldn't be reproduced. So it doesn't really matter. It doesn't really count against me. It's not a real...
That's sweeping like that runs me get full. You're like walking over. the most scare faces get like this. It's like we gotta deal with this technical debt.
Bug. Just, oh, it's irritating. And the reason that they do this, the reason that the people that write this kind of book believe in this kind of code hiding and believe in simplifying code and cleaning code this way is because they fundamentally believe that their code is perfect, and no code is perfect.
Right. Every line of code has a bug in it. I'll say it again. Every line of code has a bug in it. The only program that doesn't have bugs is a program that doesn't exist. Every line of code that you write is a potential disaster. So yes, I understand you want to write less code, but the point is not to just write less code and split it up all over the place. That's not the point.
Point of maintainable code is not to write code that can't have bugs. It is not possible to write code that can't have bugs. The value of maintainable code is writing code so that when the bugs happen, and they will happen, you can find them and you can fix them and you can write tests to make sure they don't pop up again.
Yeah, so we used to call this back in the day defensive programming. I've not heard that phrase in a long time. And also egoless programming, like where you assume a thing could go wrong or might go wrong, and this is you kind of get this intuition over time, like dealing with these issues over and over and over again. Going, if we just had a warning message here, it would have made this whole day go like 2 minutes, 1 minute, and instead of 36 hours of where the hell is this? Why is it doing this? Well, I just want to assume it was the right other one.
It's a completely naive viewpoint from the people writing these books. And a lot of people have this attitude. And usually those
They're not naive. They're not naive. The people that are writing these books are actually quite clever. They're in the space. They see the demand. They see the confusion. They see people desperately lunging at things. And the people that write these books are getting the ideas from the space that's already existing, and people like solve these things, and they try and put it together in a cohesive thing. And it's people like they push a book out there that gets to the conferences, and they people like newbies and people coming into the space like, oh, this is how you do it. It's like, well, it's just the way this guy said you could do it, and he's picked it up from other people, and he's just putting it together for you and saying this is just one way of doing it. And people are like, no, this is the way. This is the way. It's like, no, this is one dude trying to pay his bills way. This one dude like saw an opportunity, right? Because we're in a market with business. This is not a charity event. Not charity. So the people that write these books are in business. Yeah, they want to sell. So there's a lot of stuff they say, these open loops where they try and make you think about what you want to do, because by keeping you engaged in this thing, it makes them money. I know it's so sad that when you really see it this way, but this is what's going on. What do you think computers are doing? We're taking people's jobs away, people. I know this is very controversial. We are taking people's jobs away when we write code. Think about that. What do you think that, okay, you're taking people's jobs away. You're also hopefully giving other jobs other places, but not to those people. What do you think's going on here?
those are people who are developers who have never actually had to support the code they've written. They just
Right. He writes the book. He doesn't write the code. Doesn't have to support your code. He makes no guarantees. It's just ideas, man. These are just ideas, and they're not even that great. But in the absence of anything else, cohesive, being promoted, pushed, sold, people are going to go for it, right? And with all the new people that came into this space, it's more new people than old people. They're going to say, oh, this is the way you do it. It's like, no, he just did a really clever marketer. The guy that wrote Clean Code is very genius level marketing. He knows how to say it with the open loops. And if you know what that is, you look it up to make you think what he's saying is super key important. I mean, it's just, oh, yeah, it has a use case, but is it yours? I don't know. Depends, right? There's no getting around the depends. There's no getting around it depends. Sorry.
just write the code and they throw it over the wall of the ops team. And when something goes wrong, it's their problem, not my problem. It couldn't have been my problem because I had to have written the right.
So these big companies can do that for a while until little companies come along and take their lunch. Yeah, it's not that hard to take their lunch now. Lunchtime is over, or just starting for the developers who can see all the inefficiencies of doing it like this. Yeah, there's opportunity right now, but you can't do it like this. You can't follow those practices that made you like stumble over yourself. Wake up.
Right thing because all of my unit tests passed, so it's got to be somebody else's problem. It can't have been my problem. Maybe the author just doesn't.
Tests only test what they test. Even if you have 100% test coverage, doesn't gonna test all it can't test all the things the programs are doing. It's not possible. That's where these people trying to do this 100% test coverage bullshit. It's like you do know that's impossible, right? We have no way of checking if a program will complete or not. There's no way to know. You can only cover the use case, the best, the general, happy path, and a few of the edge cases. And when you find a bug, you make a new test to test that out, and You don't try and do 100% test coverage. Come on, autists. Stop.
Doesn't know any better. Maybe the author is one of those developers that's never had to actually debug.
Yeah, he's one of those developers. He did his code in the 70s when you could kind of get away with some of the stuff he was talking about. Back in those days, single threaded, like, simple machines, relatively speaking, a lot more simple than the stuff we're dealing with now. Yeah. So back in the day, it made sense, but not today. Different.
Code. Maybe the author is catering to the like prima donna mindset that these books encourage in developers and tends to be.
Yes, very much. The prima donna thing is because people actually they're doing they're projecting their insecurities, so they know that they're not they don't really got it, so they gotta project out like they got it all. It's just you that don't understand, you peon. I've got clean code. I wrote the book. It's like, no, dude. The real developers don't act like that. They're like, well, it could look like this. It could work like that. I mean, what are you trying to do? Why are we doing it like this? We could do it this. It's like, they're not like, this is the way to do it. And there are no other ways. This is the attitude of these people. It's like, oh, that you must have really have it. He must really have. He's very confident.
Present in the developers that follow these authors. Either way, it's just, it doesn't work in the real world. It's counterproductive. There are a ton of other examples from clean code and books like it that I could go through. And I'm sure others will come up in future videos, but I can't cover all of it in one video. So I think I'm going to call it here before I get too more irritated.
Like I am.
Okay. Deep cleansing breath. Remember, the internet is full of bugs, and anyone that says different is probably trying to sell you their book on how to simplify your code. Let's be careful out there.
Totally.